For this example, we're going to just keep on plotting along, and we have a region defined by y equals x to the 5 halves, y equals 32, and x equals 0. And we want to find the volume of that region that's bounded by those three curves, and we're going to revolve it around the y-axis. So since we have something that's kind of defined in terms of functions of x, and we're revolving it around the y-axis, kind of makes sense to use the shell method. We could, again, use the disk method here, but we would have to rearrange some of the way the functions are written, and let's just not do that. Let's practice the shell method. So first we're going to have to construct this. Let's say, okay, well, I have x equals 0, so that's a vertical line that goes through 0, so that's one piece of that region. And I have y equals 32, so that's a horizontal line. So that's up to 32 here and 0. And I have x equals 5 halves. I have y equals x to the 5 halves. So that's anything that's like something over a half. If it's a positive number, it's going to have that square root look to it. It's going to look kind of like this. So what I have to do is I have to figure out where that dot is actually located. So I have to figure out, what value goes here. That's not a 0. That's just a unknown. So I have to say, okay, well, I know that the output value is 32, so I have to say, okay, that's 32, and that's x to the 5 halves. So if I squared that, that would be 64 plus x to the 5th, and then I would have to take the 5th root of that. So let's say the 5th root of 64 is x. That actually tells me that x is 2. So in this particular case, what I'm doing is I'm revolving that region there. So I have to think about this. Because it's not going to be as simple as that. We want it to be. We would love it to be. It's not. The reason it's not is because that would be these heights. But we're actually dealing with these heights, right? So instead of, let me get a different color here. So instead of, these strips here, we're looking at these strips there in the blue region. Well, if I think about what the height of those strips are, let's not overthink this. The height of those strips is really, they start at 32 and they make their way to 0. So they're really the difference between 32 and the function. So what I'm really saying in this particular case is f of x is 32 minus x to the 5 halves. Right, so by the time x gets its way to 2, this will be 32 minus 32, so that height will be 0. Right, if I plug in 2 here, that resolves to 0. So in this particular case, my height is here. Now another way to do this, another perfectly good way to do this, would be to find that volume that's generated here by revolving, and then find the volume of the entire cylinder rotated around. So that would be that volume of that entire cylinder there. Would be pi r squared h, which we see h is 32 and r is 2. So it's 128 pi. So what we should know, by the way, by doing this, is that there's no way our answer should be 128 pi, or it should be as big as that. it should be smaller than this, because that would be this whole mass revolved. So if we wanted to do this without doing it this way, we could use f of x as just this function and then subtract that answer from this. So depending on how much board space we have, we might do that. Anyway, let's get started using this function. So v goes from 0 to 2. Now notice this is not drawn to scale. The length from 0 to 2 is much larger than the length from 0 to 32. Or not much larger, but it doesn't make any sense, right? That's not a point. It's not drawn to scale. So we're going from 0 to 2, 2 pi x 32 minus x to the 5 halves dx. So I'm going to do something fun here. Do a little bit of fun. Let's multiply this out and separate them. So that's going to be v equals 0 to 2, 64 pi x dx minus 0 to 2. Now I could have multiplied that all the way through, but I'm not going to for just some illustrative purposes. So if I take this right here, 64 pi x dx, and I take its antiderivative, I get 32 pi x squared from 0 to 2 I get that. Okay? Now if I plug in, so again when x is 0, this is going to be nothing. So I can plug in when x is 2 here. 2 times 2 is 4. 4 times 32 is 128. So I get 128 pi minus 0 to 2, 2 pi x to the 5 halves dx. Now, what's neat about this? Why did I do it that way? Well, that 128 pi is that. So this is the volume minus this strip. That would be, again, if you just used f of x as this. So what we see is that our actual setup here generates the exact same solution I was describing, that it's 128 pi minus this bottom strip. So let's finish this out. We're going to get 128 pi minus, so that x times x to the 5 halves is x to the 7 halves. So then we have to take the antiderivative, 128 pi minus, so that's going to be 4 pi over 9x to the 9 halves from 0 to 2. So hopefully that made sense to you. We add 1 to the power, 9 halves, we divide by that power. Dividing by 9 halves is the same as multiplying by 2 ninths. So 2 ninths times 2 is 4 ninths, and of course we carry the pi. Again, when x is 0, nothing's here, so we only need to evaluate in the case where x is 2. Having an issue here because I have an answer in front of me, and the answer in front of me is not necessarily the answer that I'm going to get if I finish this. Because 2 to the 9 halves, right? So 2 to the 9 halves. It didn't come out clean. It's going to be 2 to the 4 times 2 to the 1 half. That's how those powers split. So this becomes 16 squared root of 2. So what I end up with is 128 minus 64 square root of 2. I mean, there, 9. Now, if I get a common denominator here, I get this in terms of 9. 128 times 9, 900, 180, 72. I get 1152. I know now where I made a mistake. Okay, so this is great. This is great. I sure hope you've been paying attention this whole time because we're about to go all the way back. So, what did I do wrong? What did I do wrong? So, let's see. To the 5 halves. This isn't right. This isn't right. I doubled this side. This is a big mistake. I wasn't supposed to double that. I was supposed to square it. I was already thinking ahead to 2, so I made a mistake. Ha! Sure is funny. So, in this case, when I square 32, gosh, what is 32 squared? It's 1024, is that right? That's a 4. Which means, by the way, this becomes 4 squared, which doesn't become 128 pi. It becomes 512 pi, which affects just about everything else above this, which is fine. It won't take that much longer to erase and go. This video is just going to run long. So we're going to go boop, boop, Four, 5, 12 pi, 5, 12 pi, 5, 12 pi. So then what we get is we get something a little less terrible. So 4 to the 4 to the 9 halves, that's like 2 to the 9th. So then that's going to be 2048 pi over 9. Just trust me on that. Feel free to work that out on your own time. So I have 512 minus 2048 pi over 9. Now if I get a common denominator here, I get 4500, 4590, so 4608. I get 4608 pi minus 2048 pi all over 9. So the 8's obviously cancel, so 4600 minus 2040 is the same as 4560. So 2560 pi. Now, yuck, right? So I'm gonna do something even more terrible. All right, just bear with me. I know we're this far in. You can actually quit now if you want to, but 2 things I want to talk about. 1. I try not to prep too much before I do these videos. The reason I try not to prep too much is because if I prep for it, I'm likelier to skip steps than if I don't. Because if I have to think about it myself while I'm doing it, I'm less likely to skip over things. I still skip over things, but I'm less likely to. The second thing is, while we're here, I want to show you why, in this particular instance, it probably was better to do this with the disk method. So let's just really, really quickly do this with the disk method. Notice that I have this function here. The only difference I have to do in this particular case is I actually already know 0 and 32. If I did this with the disk method, I wouldn't even have to have solved this piece because I know my y bounds already. The only thing I need to do is get that as a function of y. Well, y to the 2/5 equals x. So this is already my function of y. So f of y is y to the 2/5. So then I could set up a washer or a disk method for that y to the 2/5 squared dy. By then multiplying this out, I get pi y to the 4/5 dy equals pi y to the 9/5 I know there's a lot of steps I skipped there, but I add 1 to the power, 9/5. I divide by that power, which is the same as multiplying by the reciprocal. 5/5 pi y to the 9/5. Again, when y is 0, that term drops out. When y is 32, I have 5/9 pi 32 to the 9/5. Now, 32 to the 1/5 is 2. The 5th root of 32 is 2. So that gives me 5/9 pi 2 to the 9th power. Now, you may not know this, but 2 to the 9th power is 512. pi. So notice that I was able to do this in what I think is a lot more short order. I did not have to solve for this. I would not have made this mistake if I were using the washer method instead of the shell method. Another reason why it's important to have these tools in your kit. By doing it both ways, I'm able to verify that I did it right. And I made a bonehead mistake here. Bonehead mistakes happen. Don't let them derail you.